Today, my video lecture on ground state energy of hydrogen atom with the help of variational method. The hydrogen atom consists a proton and a electron having potential energy minus E square upon R. This is a nucleus proton and this is a electron. Separation between them is R. So potential energy 1 upon 4 pi epsilon naught E into minus E upon R minus E square upon 4 pi epsilon naught R. But you can ignore this constant term and you can take the potential energy minus E square upon R, where E is the electronic charge and R is the separation between proton and electron. So the Hamiltonian of hydrogen atom is given by P square by 2m minus E square by R, and this can be also written as in operator form minus h cut square by 2m del square minus E square upon R. Now take trial wave function psi is equal to e to the power minus alpha r, where alpha is the variational parameter. This term can be changes for give the better result. Now apply variational method. The expectation value of h is determined with the help of trial wave function psi integral psi star h psi d tau upon integral psi star psi d tau. Put the trial wave function psi e to the power minus alpha r and their conjugate psi star e to the power minus alpha r and volume element d tau in spherical polar coordinate d tau is equal to 4 pi r square dr. Spherical polar coordinate are r theta phi, where r varies from 0 to infinity, theta varies from 0 to pi, and phi varies from 0 to 2 pi. So putting in this equation, h is equal to e to the power minus alpha r and capital H is equal to minus h cut square by 2m del square minus e square by r e to the power minus alpha r 4 pi r square dr upon integral psi star psi e to the power minus 2 alpha r 4 pi r square dr. 4 pi is cancelled in numerator and denominator, and separating these two equations, then you will get this. Now solve the denominator e to the power minus 2 alpha r square dr using beta gamma function. 0 से infinity x to the power n, 0 से infinity r square, मतलब x is equal to r and n is equal to 2. n is equal to 2. E to the power minus 2 alpha r e to the power minus alpha x. So alpha is replaced by 2 alpha. So formula is n factorial upon alpha to the power n plus 1. That means 2 factorial upon 2 alpha to the power 3. 2 factorial means 2 upon 8 alpha cube या 1 upon 4 alpha cube. This is the value of denominator in both terms. Now take numerator. First term of numerator e to the power minus alpha r minus h cut square by 2m del square e to the power minus alpha r square dr. Put the value of del square. Del square is equal to divided 2 upon divided r2 plus 2 by r divided by divided r. So del square is equal to divided 2 by divided r2 plus 2 by r divided by divided r. So both terms are separated. Divided 2 by divided r2 e to the power minus alpha r. This term does not differentiate by divided 2 by divided r2. So divided 2 by divided r2 e to the power minus alpha r, 2 times differentiation in one time minus alpha e to the power minus alpha r, again minus alpha square e to the power minus alpha r. So first term becomes this, and second term divided by divided r 1 times, so second term becomes this. Now again apply the formula 0 to infinity x to the power n e to the power minus alpha x dx is equal to n factorial upon alpha to the power n plus 1. This term also r के power 2 x to the power n, मतलब n बराबर 2 and alpha is equal to 2 alpha. In second term r की power 1 n is equal to 1 and alpha is equal to 2 alpha. So after applying beta gamma function, you will get this term and e to the power so e to the power minus alpha r, this term becomes is this minus h cut square by 8m alpha plus h cut square by 4m alpha. Now take last term e to the power minus alpha r minus e square by r e to the power minus alpha r square dr. So after applying the beta gamma function in this term, you will get this. Now putting in equation number 3, then after solving we will get the expectation value of h is equal to this. H expectation value can be written as E. E is equal to H expectation value H cut square alpha square by 2m minus E square by alpha. Now differentiating with respect to alpha. So minimize the energy using the condition of minima dE upon d alpha is equal to 0. So the value of variable parameter alpha is E square by m upon h cut square. Now putting in energy equation, you will get the minimum energy for the variable parameter me square upon h cut square is equal to this. This is the end of my lecture.